So, ladies and gentlemen, this is Team ELMO and my name is Seppo Meri. And our aim in this project is to eliminate mosquito-borne illnesses with two methods. One is to really develop new types of mosquito nets, and the other one is a vaccine. But since there's not enough time, I will leave the vaccine out from my presentation here. So the main aim is to combat malaria. Every year there are about 200 million people who get infected by malaria parasites, and approximately 500,000 people die, mostly children in Africa, because of malaria. So the principle in our mosquito net is that it lets mosquitoes to fly through to one direction but not back. And when we take two of these nets and put them into windows against each other, then the mosquitoes will be trapped in between. And we think that this is a very good solution, because we don't really need any external energy sources for this, and we don't need insecticides. And there's a problem that the mosquitoes nowadays, they have started to develop resistance against insecticides. So we have tested our concept extensively in the laboratory. We had many different prototypes that we tested and came up with one good solution, where more than 90% of the mosquitoes went through, but none of them came back when we had a very strong natural attractant there at the other end of this test tunnel. So we have also gone to the field in Africa. We have field trials going on in Tanzania, and these already show very clearly that the concept also works in real-life conditions. So our next challenge really is to put nets into a whole village in Africa, so that we can really find out that or document that the net solution would reduce malaria in that area compared to a control area that we will have. And in addition to work in biology, in technology, we also have team members who work on the societal aspects of this solution. And if we can reduce malaria in Africa, in certain areas and in other areas in the world as well, this would lead to better chances of children to go to school, for adults to go to work, and by this it would also improve the economies of the countries. And of course, African countries would be more attractive to tourists to go if there is no risk of malaria, or the risk is less than it is nowadays. So our team is composed of people who are experts in mosquito biology, in medicine, in malaria. And also we have engineers from the Tampere Technological University who have really made these nets in practice. We have also a group from Aalto and Hanken universities. They analyze the impact in the field and the implementation of the solution into field conditions. We collaborate with 4 different companies that also help to manufacture the nets, and also all these implementation aspects in the field. So our ultimate aim is to save human lives, and we really hope that this Helsinki Challenge project will help in this. So thank you very much.
Thank you. Any questions considering mosquitoes? There we go.
What happens to the mosquitoes when they end up in the net? Are they eaten?
When the mosquitoes are in between the nets, they will die within a day, or maximally within 2 days, because they are in dry conditions, and if they can't get anything to drink or eat, they will die there. And especially in Africa, in the drought and the heat of the day, they wouldn't survive. And then, of course, they end up being dead there, and we would have a practical means, just using Velcro tape, for example, just to lift the bottom part and then clean them away. If you want to eat them, why not? You can make cakes. Birds love to eat mosquitoes as well, so you can feed them there, but the mass amount of food is not really that great, at least not for human consumption. So.
A very good question, though. There's another question over there.
Hi, what's the estimated cost per household?
So we have estimated that the final cost of one net for one window would be like $1. So they are very low cost. And if the manufacturing is done locally in Africa and also the assembly to the nets, then the price would go even down from that.
More questions?
Is this biodegradable? If after the use, you can compost that or something?
So we can use or make the nets from different materials. They can be made from biodegradable substances like from cellulose, but they would not necessarily last so long. So it's probably better to have them made from a strong structure that lasts for a long time. So they are no different from the existing nets at the moment in structure.
There's one more question over there.
Thank you. Very good presentation. Tourism-wise, how is it better than the malaria drugs?
Sorry, I couldn't hear.
Tourism-wise, like as a tourist, I can take a malaria drug when I go somewhere.
Yes.
How your solution is better than the malaria drug?
Well, they are synergistic to one another. So we know that the drugs that you take to prevent malaria, they are not 100% protective. So they are good and they are very important if you go to areas where there is malaria, and especially if you go there during the rainy season. So always having a double protection is better than having only one. So no one single solution alone would be effective at the end to really eradicate malaria from an area. So you need both. But the problem with the drugs for malaria and then also for the insecticides for mosquitoes is that there's resistance in both occasions, and there's always a need to develop new drugs against malaria. And now in Southeast Asia there is resistance in malaria against all drugs that exist. So that's a continuous problem.
But as far we don't know of net-resistant mosquitoes, right?
There might be one clever mosquito that finds the way through from the other direction, but so far we haven't found a single one yet.
Then, I mean, if mosquitoes can learn, what did you learn as a team during the year?
I think this has been really like a mind explosion to us. So we have learned to what means co-creation, and we have learned publicity, and I ended up in a video with Madonna, which of course could be for the good cause, and so many things, in fact, that are different from the normal life of a scientist, as we heard already
Great.
previously.
Thank you. Thank you very much, ELMO.